Hello, Wharton Warriors. Today we're going to solve 2023 AP Statistics free response question number 5. So let's look at the question. Wildlife biologists are interested in the health of two elk. So they measured their chest and circumference and weight and then released. So data for 30 male two elk are shown in the scatter plot. Okay, as you can see, it asks to describe the relationship between chest circumference here in the x-axis and weight of the male teal elk, which is y. You would immediately notice that there is a positive relationship here. So if you draw a line of best fit, you'll notice that there is a strong and positive linear relationship between chest circumference and the male teal elk. So if you could just figure out these three words here, you'll be good to go. Okay, so the next question asks you to use the equation of the least square regression line, calculate the predicted weight for this male teal elk. What could we get for this elk for weight? So the estimate of weight, as you can see, this is the equation for our line of best fit. So all you had to do is just put this number into here and see if this equation gives us this weight. Our predicted weight hat, is minus 350.3 plus 3.7455 multiplied by our chest circumference given 145.9 centimeters, which gives us 196.17 kilograms. Okay, and what is our residual? Residual is the difference of the true value y and the predicted value of y hat, right? What was the true value? The true value was 204.3 here. And what was our predictive value? This is our predictive value, right? So minus 196.17, which gives us 0.13 kilograms. So we missed about 8.13 kilograms, which would be our residual. Okay, so the next question says that using the same line of the best fit, we have to interpret the slope of the least square equation regression line in context. In normal linear relationship, we would have slopes, right? What is our slope? This is our slope. So what does our slope tells us? For every increase in of 1 centimeter of the chest, so this is x, right? So every 1 centimeter increase here, the weight increases about the predicted weight, I should say, predicted weight for male teal increases about by 3.7455. So this is our slope, right? So here you would say that every 1 centimeter increase here, the weight increases about 3.7455 kilograms. Okay, so let's move on to the next question. Here, the question asks, we have two hypotheses here. So null hypothesis, our beta, which is the slope of the population regression line, and the alternative hypothesis is that the beta would not be a 0.5. We should use our t-distribution, right? Because this is not one-tailed t-test, because you have to find the either side that does not make 4.5. Okay, so this is a two-tailed t-test. And here's the one important evidence here. The test statistic t was calculated as 3.408. What does that mean? This is actually our t statistic, right? So if you draw a plot, our minus 3.048 would be here, and plus 3.408 would be here. So the probability that the value beta would outside of this range, right? So this is a two-sample t-test, as I said. How many degrees of freedom do we have? Degrees of freedom for t-sample t-test was the number of samples minus 2. So in this case, since we had sample of 30 elks, we would have degrees of 28 degrees of freedom. Okay, so in order to calculate p-value, we need 3 values. So we would need the lower bound, the lower bound of 3.408, and the upper bound is just the maximum value. Okay, so I would say 9999, and then the degrees of freedom 28. So if in the t distribution, and this multiply by the original z-score. Okay, so if you look at these values on the table, if you look up these values in the table, you would eventually get the p-value of 0.002. Okay, all right. So at a confidence level of alpha equals 0.05, what conclusion should we wildlife biologists make regarding the population regression line? What was our true null hypothesis? Our H0 was true value was beta equal to 4.5. And this means p-value equal to 0.002 means that there is a 0.002 probability of getting obtained sample slope or more extreme either direction. So this is a lower chance, very lower chance. Okay, so or more extreme in either direction by purely just by chance. So since we have a significant level alpha equal to 0.05, this is much more greater than our p-value, right? And what do we have to do? In this case, we have to reject H0. And we do have convincing evidence that the slope of population regression line for male elk to elk is different than 4.5 kilograms per centimeters. So this would be our slope, right? So we have to say that we reject it, and we do not accept that the male to elk is different than 4.5 centimeters. I hope this video was helpful, and if you have any questions, please leave them in the comment. Thank you.